Now you're recorded forever.
Okay, all right. Okay, so I'll talk about future instrumentation needs, and this is not an all-encompassing or general thing, because as you know, scientists say more data are needed. But this is really in the context specifically of
You have to click on that. Oh, there you go.
okay, specifically in the context of SC4D, subduction zones in 4D. So what is SC4D? This is a very quick recap because you probably already heard
These are
about
nice slides.
Oh, it is a community-driven initiative for long-term interdisciplinary research to understand subduction zones, so space and time.
No, they're just, I think they're,
Don't say anything you regret.
We're getting some live commentary.
Who is
Oh.
it? Oh, here we go. Well, I think,
Well, Scott has to stay on.
I think, yeah, we need the person here.
Good thing this is recorded for posterity. All right, so specifically in terms of SC4D, this is related, or what's relevant for this group here is magmatic drivers of eruption. So that's the goal, is to understand what are the magmatic drivers of eruption. And so this is a figure taken from the implementation plan, SC4D implementation plan. And it looks at questions like, for example, crustal magma ascent rate and how that may relate to eruptive processes. And Diana talked a little bit about this difference between things we see in seismicity, for example, that are top down versus bottom up, that may be related to crustal ascent rate. So ascent rate may be very fast. I guess this should be the highway from hell, not to hell, but I didn't, it's a graphic, I couldn't fix that. And versus magma that may have been sitting in the crust for a period of time, gets remobilized and triggered and results in eruption. We also want to look at things like the magma reservoir depth. So at where in the crust is the magma stored in periods of time up to eruption? That may be very shallow, that may be very deep. One of my favorite volcanoes, Okmok, it's really just a couple, 2 or 3 kilometers below the surface is where the main shallow crustal magma storage is. But in other places, it's several kilometers deep. So what is that magma storage? How is that related to eruptive processes? So SC4D compiled, the magmatic drivers of eruption group compiled a series of hypotheses that are ultimately testable by collecting more data. So one hypothesis A here, gas and magma composition are linked to eruptive precursors, to run-up times and eruption intensities. Hypothesis B, mantle magma production and supply rate is linked to the intrusive, extrusive mass budget, crustal residence time, repose time, and evolution of crustal magmatic architecture. And hypothesis C, the periods and drivers of different external eruption triggers over time scales of minutes to over hundreds of thousands of years are all linked. So details are in the implementation plan. All right, I'm not sure what that sound is coming from. But to address that, we need to collect data from a large number of places.
I think it's the timer.
At Granger?
This is because we recorded.
All right, there's another window with a video. Oh,
I know. I can't get to it because of this box.
all right.
Or
For advertisements.
you have the most exciting talk today.
So that's our new funding model.
Oh, it's still recording all this. Lovely.
All right, well, you can probably edit the Granger commercial.
Yeah. Nothing a little editing can't fix. Okay. Let me make this go. Yeah, there we go.
There we go. Okay, so to really get at those hypotheses, we need to collect data from a lot of different places. You can't just look at 1 or 2 volcanoes. You need to be more systematic. And so SC4D has a primary focus in Chile. So that's actually where the majority of the instrumentation is going to go, but with complementary efforts in Cascadia and Alaska. And so, so again, most of the effort is going to be in Chile. There will be some in Alaska. And what SC4D has done is chosen a set of target volcanoes spanning the three regions. So we do have a concrete plan to build more infrastructure. There is going to be a proposal going in to NSF's mid-scale research infrastructure program, specifically called MSRI-2. And this has a cap. It's a $20 to $100 million construction budget. So that is for construction, which is putting things out. It is not for operation. Operation has to be supported by NSF, Earth Sciences, Geosciences, or God knows whatever happens with the NSF's reorganization. So the operations and maintenance also must be affordable to NSF, whatever we would put out. Right now, what we understand is that the solicitation for MSRI-2 is expected in fall sometime. So that means a pre-proposal will be due early in 2026. Diana Roman is going to be the PI of that proposal. If that's successful somewhere, we think in late 2026, we have to put in a full proposal. And if that's successful somewhere in 2027, 2028, things start getting built. So again, the instrumentation proposed for this are three essentially linked observational arrays of instruments. One focused on earthquake problems, one focused on volcano problems, and one focused on sort of surface process problems. Here in Alaska, really the first two are the ones that are going to get the bigger effort. And again, there's three sort of nodes for this array. The biggest one will be in Chile, Cascadia, and Alaska. So this summarizes what is happening for earthquake array. A lot of this is actually going to be offshore instrumentation to look at earthquakes, megathrust earthquakes. And then for volcano array, 5 volcano sensor arrays in Alaska. So the target volcanoes are all listed here. There's a number of them in Chile. Again, in Alaska, there are 5: Spur, Redoubt, Augustine, Pavlov, and Shishaldin. So these were selected by a magnetic drivers of eruption working group. We want some feedback, but part of the reason is we also have to do prioritization on these. So in terms of the earthquake problem, there were initially 3 locations identified for Alaska. One is Prince William Sound. Another one is in essentially the Alaska Peninsula region, where we're looking at variation of interface behavior, plate interface behavior, and further into the easternmost Aleutians. There will have to be some reprioritization or pruning of the plan. I'll get to that in a minute. And here is just a blow up of the Alaska target volcanoes. So there's not an enormous degree of synergy between the earthquake deployment and the volcano deployment, I think, for Alaska. But obviously seismic stations, for example, around these volcanoes will help with earthquake studies and so on. So what do these volcano sensor arrays look like? This is sort of a nominal figure. So again, for Alaska, Spur, Redoubt, Augustine, Pavlov, and Shishaldin were the 5 targeted volcanoes. There will be a number of instruments. Now, as Max just showed you, some of these instruments already exist. So there are seismic networks on all 5 of these volcanoes. There are, except for Pavlov, there are GPS on all of these volcanoes. But many of the other kinds of instruments aren't there. So one of the things that will happen for Alaska is looking through the full inventory of AVO's networks to say, okay, what do we need to add to flesh out these sensor arrays on each of the target volcanoes? And so it'll be adding strategic new stations, adding new kinds of instruments that aren't there presently, and so on. So I mentioned that we have to do some prioritization. So we came up with a wish list is maybe a little bit too extreme, but we came up with an initial plan for this. And as you might expect, the initial plan costs more than the budget cap. So we have to go and reduce down to get to the budget cap and do that in a way that sustains the most important scientific objectives for all 3 components of SC4D. And we also don't want to just X out a region entirely. So there has to be some judicious some judicious prioritization and planning. So so input is needed now, I think, on that of that list of target volcanoes. And again, in the case of Alaska, because a lot of instrumentation is in place, we want to focus on what are the new instruments to be added that will be most impactful at addressing those hypotheses. So in addition, there's a new effort that's been funded, what we call the design proposal. And so for volcano arrays, this is focused on some simulation sort of study. So basically trying to optimize the design of these networks, come up with some defensible measures of how precisely can we measure certain things given certain kinds of instrumentation and so on. And this will inform the final design of that. What will also, I think, inform the final design is input from community scientists. And so, for example, if we have to drop from 5 to 4 of these volcanoes, well, what are the priorities? What do we lose by losing a particular one? We need to hear from you guys about that. There's not a huge amount of time for this process, but we do need to hear from the community about that. And this workshop is a great opportunity to get some input to help guide those decisions. So the scope refinement on all aspects of SC4D are really to optimize the plan based on quantitative analysis of current capabilities and resolution simulations. To optimize and refine the footprint, and again, identify exactly where existing infrastructure meets the needs and where targeted improvements will allow us to actually address the necessary hypotheses. And so input is needed from local experts and stakeholders, and that for the next, that means you. So what can we add at these places? I think this is my final slide. I'll just double check. Yep. So this is kind of the message to hopefully seed some of the discussions that we have here in the next few days. What can we add at these volcanoes to get closer to this sort of nominal idea of basically multi-parameter sensing? And what do we need? You know, what are the highest priorities to allow us to address those hypotheses? So again, think about questions related to magma ascent, magma storage, and so on. And let's see what we can do. Thanks.
Some questions, if anyone has any.
Last one. On your event.
Well, I mean, I think very, I think would be the answer for some of this. So that becomes an interesting problem because it's not easy to get close to the vent. Things are likely to be destroyed if they get close to the vent. But those may actually measure critical things that you can't measure anywhere else. So we need to look at that. For example, I think in terms of GPS, which is my expertise, certainly for Shishaldin, based on what we've seen from deformation data, you're going to have to get in very close to see something, and that's going to be an instrument that's likely to be in danger when it does erupt. So yeah, we need to think about getting some that are in very, very close. One kind of anecdotal example, when Augustine erupted, there was actually a avio station where there was a temperature sensor just to sort of monitor ambient temperature in the hut. It turned out that as it was getting closer to eruption, the temperature kept going up. So it was effectively it was not intended to be a temperature sensor for the volcano, but effectively was. So yeah, I think we need to look at getting in very close for some of these instruments. Yeah.
Just curiosity, why were the Cascade volcanoes? It was like Hood, Three Sisters, and then like.
So I was actually not part of that working group, so I actually can't answer why they chose those particular ones.
We met with the Cascade Volcano Observatory and had discussions about where they would like to see instrumentation in long term, because they will adopt it, and there are interesting aspects of those three systems to them, including where they see needs for instrumentation. I don't know if Jeff, you want to add anything? And Diana?
Yeah, just to add on to this, the ones you're seeing in red Just focused because in Alaska, we're not doing any, sort of IMUSH scale things.
Mhm.
But the red ones are basically targets for dense imaging, using seismic, gravity, MT, as well as that longer term monitoring, so, part of the choice as well is, in the chilling ones as well, so we've got 6 that we're trying to also do kind of a more dense instrumentation on for a shorter time period, that sort of, again, together as a group, help test those hypotheses, so that was part of that.
Right, yeah, I didn't mention the volcano imaging arrays, which is another part of the, because none of them in Alaska were proposed just because of the access limitations. It's kind of hard to put 1,000 seismometers or something like that on any of the volcanoes in Alaska. But yeah, that's what that. And as I said, I was not part of the working group, so, but we've got members of the working group here, so they can answer those questions. Yeah, Terry.
Yeah, Terry, first.
Is there an overarching reason why these 5 were chosen, or it's just, oh, they're active and they're different?
So I think they were looking
We
at,
really need Pavlov and Shishal, you know?
I actually asked exactly the same question, Terry. Again, I think you want to toss that maybe to Madison. But there were goals to find similarities and contrasts between volcanoes in different subduction zones. So so it wasn't just oh, here's 5 interesting ones. There was looking to capture a variety of parameters essentially for all of them. Yes, I would say Pavlov and Shishaldin seem pretty similar to me, but there were reasons why they were chosen. So
And part of it was also meeting with local stakeholders, so just kind of, we met with people in Chile, for instance, and they came up with this list, and the same thing with the Alaska Volcano Observatory. So some of this is for comparative across arc aspects and sizes, or other aspects that could be compared, but others was just like, what do we see as gaps from the people that are gonna have the instruments at the end of the day? That's my best answer.
and is there time for Steve's question?
Yes.
Yeah, this is a very technical question. Given that you want to have the station coasts are likely to be covered with snow, are there any changes or improvements in antennas and such things? Like, will the station still work if they have light snow cover or 3 feet or whatever? And if not, can you put a mass storage device so at least the data would be collected to be picked up later?
Yeah, so I think that's a good question. I mean, I think in terms of storage of data on site, that's, if anything, getting easier these days. But for example, like, I mean, Max showed the picture of the top of Mount Susitna. If that was a GPS antenna covered in ice, you're not going to get you're not going to get usable data, because the signals passing through the ice are actually being delayed in a way that messes with your position. So in some ways, those environments, you may only get, for certain kinds of instruments, you may only get reliable data for certain times of year. I think storage on site is certainly feasible. But eventually you have to get the data out, and the closer it is to in harm's way, the more important it is to get the data out without having to visit it, and so on. So yeah, there are going to be some trade-offs, I think, between the practicality and what the scientific needs are.
Well, yes, one more question, quick.
Okay, so I am from Purdue University, so I wanted to see if there are opportunity for people to, or other the single PIs to supplement the instrument you have for the sensor really to do some imaging. How would that happen?
Yeah, that's a great question. So let's suppose that this whole thing gets funded and all these instruments get put out, and then you've got an idea that you want to put out, some additional instrumentation on one of these volcanoes. Absolutely, make your case to NSF. It's the kind of thing when you've got something there and you have an opportunity to piggyback on that and do something else. I think as far as I know, there's not going to be like a science program specifically that you would propose to. Maybe they will decide there is. I don't know what they will ultimately do. It would be great if there was, but yes, I think you will. Anytime we've got instrumentation anywhere, there's always the opportunity to say, hey, if we add this, we can answer this specific question. And I think there's also opportunities for people looking at other volcanoes. I mean, I think these are great volcanoes, but there's a lot of great volcanoes in Alaska. So, so if you don't see something on the list that is appealing to you, it doesn't mean that you can't work there. It just means you write a proposal and we cross our fingers and all
A
that.
lot of fingers.
Yes.
Yeah.
All right, thank you so much for that. That was wonderful.